Before we begin, what I'd like to do is just very quickly talk to you about why GIS. Just give you some idea why it's vital in the whole addressing problem and how it can be used innovatively to solve this. I then want to introduce you to Arcgis Server, which is a web-based GIS services platform, and some of the functionality that you can use from that. Talk about the APIs and libraries that are available from ESRI to interact with Arcgis Server, and then to have a look at the data sets that have been made available and how you can interact with them. So I think firstly, why GIS? So if we think about all the data that's around us, at least 80% of this data has got a locational component to it. So it's somewhere in the world. It can be static, like a house. It can be dynamic, like a vehicle that is driving around or a person that is walking around. And with the smartphones becoming more and more ubiquitous and available, everybody basically has the sensor package on them now that can give them a location, that can take photos, that can record video. A lot of them have got accelerometers in them, so you can even look at which way the phone is pointing, which way it's oriented. So this makes spatial data a lot more easy to capture, and it's basically almost in anybody's pocket. Now, what GIS does is it brings this geography or locational data together with attribute data. So if we think about that, if we look at an address, it's a point somewhere on the earth. It's got some attributes. It may have a street associated to it. It may have a street number associated to it. It could be in a suburb, in a city, in a province, in a country. All of these relationships between that address and the other entities like cities, provinces, countries can now be inferred from that location, because this point falls within the city or within the country or province. Other relationships and so-called spatial relationships can also be looked at. It can be close to a street. It can be near other points of interest. So where with normal relational databases, all these relationships would have to be keyed, i.e. primary key, foreign key, address in city, address in province. This can now be inferred by means of that location. And this makes it possible to do analytics and to bring data sets together that otherwise you would never have been able to do, or would have taken a tremendous amount of effort. So, if you've got questions, please stop, ask. Okay? So what I want to do is introduce you to ArcGIS for Server. So the idea of ArcGIS for Server is that it's a platform that hosts GIS web services. Now, GIS has evolved from the early 70s to today, where it started on single computers, mainframes, workstations, and basically working in isolation. But with time moving on, it has become more and more of a way of sharing data, and also it's been evolving into something that makes it possible to share data over the web. So where the real power comes in is when you can start bringing making this data available through a way of services. So what we can see here is, let me just get the laser pen up. We can have a server sitting on either a cloud-based environment or within a data center or within your organization. That won't work. That's for the other one. We've got a web, which can either be an internet or it can be a LAN. It doesn't have to be on the internet, but better when it is, more available. Obviously, you need security for that, and that is built in from transport security to roles, groups, users with their privileges. And these services that we just spoke about can now be used by desktop applications, web applications, or mobile devices. What I'd like to do is just take you through a few of those web services that can be made available from Arcgis server, and what you could use them for, and how you would consume them. So the first one would be something that is called the map service. Now, the map service makes it possible to do an imprint of a map as a graphics file, a PNG or a JPEG, or a scalable vector graphics, whichever one you want. You can request that from the server. The requests are made over HTTP protocol as REST JSON or as SOAP. So that makes it possible to return an image, as we can see here. What we've done here is this is just a browser, and we are requesting through this browser an imprint of the base map of Johannesburg. If we open our developer tools in the browser, we can see that we are requesting this data, and a number of PNG images are coming back within a few milliseconds. What you're seeing here as well is a way of scaling out the services, which is called caching. And here what is done is that the map imprints are pre-generated as PNG files at specific scales in things we call little tiles. And what's happening now is the request to get this map back isn't that it actually has to draw the map on the server and return it. It has to say, you zoomed in this far, you're in this area, therefore I'm going to give you all these tiles there, and it can return very quickly, and it can cache it on your local device as well, so that your subsequent interactions become a lot quicker, because it sits either in your mobile device cache or in your browser cache. Yes?
I would like to find out if you write a mobile app for someone to use this and it caches locally, wouldn't it charge a lot of data costs for the user?
That depends on how you would request it. It's going to have to return data in any case. Okay, so there is going to be some bandwidth that you're going to use, but the fact that it caches it means that you only got to request it once, and not every time you want to draw the same map. So in a sense, that is going to save you data and money. You can optimize these by making use of PNG or JPEG. And the other nice thing about the tile cache is it only extracts for the area you're interested in. If you want to go offline, yes, then you'll have to cache an area, and then you have to be pretty careful about how much you want to draw down. Looking at the base map of Johannesburg here, if you want to go down to a scale of 1 in 1,000, we're looking at about 30 gigabytes. So you got to be careful what you ask for. Okay. Another question, sir?
So you talked about maps which come as images and features. What are features?
Can we just wait for the bus to go by? Actually, yeah, if you could please use the microphone when you ask the question, that would make it a lot easier.
Hi, oh, it's loud.
Yeah.
You talked about maps as images and features as JSON or XML. What are the features? Is it metadata about the images which are returned? What are the features? Which
What
are
is that?
returned? It's JSON.
Okay, what that is, and I have to get to it still, is this is the actual data. So this is, we just spoke about GIS bringing the attributes and the geography or the location together. And this is literally a structured text format, the JSON, which would contain the coordinates. So let's say it's an address which is a point, it would have a latitude and a longitude. And then it would have the attributes in there as text. So what we can do is, I'm going to take you through the data sets and I'll quickly show you what comes back. So think of it as a JSON representation of a record or a number of records that come back. And this you can use to display data on a browser or on a device. And you can also do rendering, i.e. drawing that on the map locally on that device. That answers your question? Yeah, good. The next one of the services that are exposed are feature services. The idea is that it would, just like the map service with the JSON, would serve out the geometry and its attributes over the internet. It would provide the symbology, which is the way in which you want it drawn. So you could make an address be a round point or a square or some little graphic to make it look nice. Similarly, if you draw areas or polygons, you could color them in a certain way. Lines you could show as a certain thickness. And this can all be rendered on the client. So that can take a lot of the stress of the server. So remember always, if you're going to have a social app, you're going to work at scale. If you're going to have a lot of people hitting it, you don't want your server to slow down too much, because then it's going to cause frustration with your users and it's going to become less popular. So it's quite a fine balance that you have to work with. The feature services here are mainly for performing edits. So what happens is you've got a client on the web or on the desktop. It connects to the server and it can edit or create data and store that in a database. So if you want people to walk around with a mobile device, capture addresses, or make observations, this is typically what you would use to create data or to update data. Another service that is available and that we're using are the so-called image services. So this is an image where we are right now at the DIZ. It's used for serving out very large imagery data sets and only returning that little bit that you're interested in at that specific scale. This is 2012 aerial photography of Johannesburg. And once again, as you can see, within a few milliseconds, it returns an image to the device. The next service type, which is also very interesting, are the so-called geoprocessing services. So the idea behind the geoprocessing service is that you can have a certain analysis that you can design, and you can expose that to your clients over the internet. So what we're looking at on the right here is a so-called geoprocessing model. It consists of data sets and processing steps, outputs, and some parameters. And it can combine a number of these processing steps or tools to create an output. And this you can then customize using a few parameters to generate an output. and these can be called over REST or SOAP calls. What we're looking at here, I don't think it came out too nicely, but it's a geoprocessing model that estimates the amount of load on, or traffic or load on the roads in Cameroon, where you're trying to estimate how much tonnage is being transported per year for a certain commodity over these roads. So you can't do that for everything, but by parameterizing it, you can allow the user to select specific attributes or specific tonnages and thereby create a certain scenario and share that output. For addressing, well, that's what you're here for. You now have to go figure out a way of using this, making this available. The tools are there. Now it's how you use them and combine them to come up with a solution. There are some utility services, the so-called geometry services. So this allows you to do specific operations on geometry. So we can do things like buffering. We can take a specific point and we can say, create a buffer of 100 meters around that, and go and look for all other points or for all other streets. So you can do queries like proximity with that. You can project, go from a latitude, longitude projection to a transverse Mercator projection. There's a whole map projection science behind that, and these would be tools that would allow you to do projections on the server. The JavaScript API, which we're going to be talking about soon, also makes a lot of this available on the client, so you don't have to do the round trip if you want to make your applications more interactive. So once again, it's a call over SOAP or REST JSON. The pattern we use to share all these services, these are not all the services. There are lots more. We're going to share some URLs with you so you can go have a look what else is available. So the idea behind this is to author, share, and use. So authoring means basically defining what you want on your map using desktop software. You can define layers, you can define the symbology, how it's drawn, how it's labeled. You can show at what scales the layers are drawn, switched on or switched off, and you can set definition queries to filter what you want displayed. They are shared as services, so you give this a name, you add metadata tags to make them discoverable, and you set security privileges so that only certain people or certain groups of people can do certain things with those services. Then we get to the use. And the use is typically via the developer APIs, the application programming interfaces, and the libraries. So these can be on desktop, they can be on browsers, they can be on mobile devices, and you will interact with those services. So, the most basic API that's available, and it's sort of the lowest level, is the REST API. So what the REST API does is it allows you to use these services through HTTP calls. It's got a browser-based interface which returns HTML, and it gives you a way of quickly discovering what's available in there. We're going to go through the data sets that have been made available later in the talk, and it's going to show you also how to use some of those. There is a full online reference on how to use it, how to make those calls, and we will be sharing these on the website, these URLs. So what you would do, and what you would typically do when you prototype stuff, is you would literally be sitting on a browser and you would be constructing these URLs to request certain services and certain information. Then, the first API I want to talk about is the JavaScript API. It's used for building browser-based web mapping applications. And these can run on devices, these can run on desktops. I think it's possibly the most cross-platform way of making these GIS services available. There's a reference online for it. If you watch a web app written in JavaScript interact through your debug tools that are available in most of the browsers now, it's F12 on Internet Explorer, Chrome, I think Firefox as well. You can see that what it does behind the scenes, it creates those REST API requests to request map tiles, to request features, to do analysis, and to interact with the map, which is then returned and displayed in the browser. Then we have the so-called native application APIs, where you can start leveraging the power of the specific device you're working on. There are specific ones for Android, iOS, for Java, .NET, OS X, but then also the ones called Qt and Xamarin, which are more cross-platform, that you can write in C++ or in Xamarin. Obviously, your performance is going to be better if you go on the native device. You can make use of the specific capabilities of the device. So if you want to start working with the accelerometer on your phone, it's easier when you work in an Android or in an iOS application because you have access to that on a lower level, and also the mapping application. The price to pay for that, of course, is now you are less cross-platform and you're working in a lower level language. So once again, it's a balance as to what would suit best for you. I would suggest that you first make your pitch, first decide on what you want to do, and then have a look at the technology you want to use so you can see what you can get away with. Don't immediately dive into the hardest, most difficult API if you can get away with a few REST calls. That brings us to the data sets. The data sets that we've made available for the GeoJosie competition are hosted on an Arcgis server. They are available over the REST APIs and the other APIs. What I'm going to do is maybe just quickly take you through them, and then also just show you the specific websites that are available for this various APIs. I think let's start off. I'm just going to sit so I can type a bit easier. Tell me if you can't hear me anymore. I think we're pretty much done with this. So, I can end the slideshow. So here we go. This is the so-called services catalog. If you go on the internet to services.geojosie.joburg, server REST services. This is sort of the root part of it. It's hyperlinked, so you can basically go from into various folders or get into various services. So we can see there's something like Arcgis data, there's a base map, there's aerial photography, and there's a geocode server which you can use for geocoding addresses. Let's take one of the services. There's a base map here. I've got that open already. So what would happen is, let's maybe just go through. From here, we open the base map. And we can now see a description of this map server. So we can see it consists of a number of layers, from street center line to addresses, regional boundaries, ward boundaries. Each one of these layers we can hyperlink into, and we can see what type of queries are available on that. We can see the extent, how it's drawn, and the attributes. So we can look at things like street type, street name, street node, status subtype, query. So here we can now start prototyping and generate a typical query, and it's something like street name Smith Street. We want to get all the fields out. We want to return geometry, and this request we want to get the results back as HTML. So this is a normal HTTP GET. What I'm going to do is I'm just going to open my browser debug tools so that we can see what this GET request does. And there we go. We get some data back. Let's see what it got. So here at the bottom we can see Smith Street and various Smith Streets that came back. Now, however, HTML is not quite the way you want this data back, because that's something that you'd have to scrape. So you would want to change this and turn this into maybe JSON. Let's do that query again. And now it returns the information as JSON, which can be parsed using anything in JavaScript or Java, C#, lots of libraries to be able to work with that. You can look at what came back. So in the header, it would tell you about the fields. It would tell you what type of geometry it is. It's a polyline, it's a street, it's a linear feature. What its spatial reference is, so how it's projected. The fields that are in there and their types. And then we've got the actual features themselves. And here you can see what it consists of. So you can see there is an object ID that's a number, a street key that's a number. It's called Smith Street. And it's got a length of just over 3 kilometers. And then there's a list here of the actual coordinates that the street consists of. Now, this is very low level. If you use something like the JavaScript API, it's going to be able to interpret this for you, put it in a table, render it in your application. It'll be able to take the list of coordinates, turn it into a geometry, render it on your browser if you want that. So the other part of this, and let's just go back one. So you have the ability to explore these services, see what's available, prototype queries, have a look what you can do with it. I'm just going to close this guy. Come on. So let's maybe take a look at one of the other services. There's the aerial photography. It's an image server. We can preview this, and here we're making use of a very basic JavaScript application to just render the service for us. So there's the aerial photography of Johannesburg for 2012. Once again, if we hit our debug tools, oh no, I haven't got my mouse here, but okay. If we start zooming in, you can see the detail becoming more apparent. There we go. This is the way to Stadium, if I'm not mistaken. And you can go to quite a level of detail on this. There we go. Should be able to figure out what type of car that is. No, the number plates, no, that's got a view from the side. So once again, we can look at the time it takes and the request that's being made to get this image back. The APIs will generally do this for you. If you want to do your own thing, you can use this and construct these queries. What else was there in the services catalog? Okay, yeah, we had this. This is just the base map itself. We use the base map to give reference to where we are on the on your device or on your map. As you zoom in, you can see much more detail becoming available. And this map we have cached. So what we should see, and I keep bringing the developer tools up, is that as it comes back, you just see it's basically already in my browser cache. So we don't see any network activity here. Let's start zooming. Now we start seeing the images coming back directly, and you can see it's basically just a request off the disk. So it's very, very quick. It doesn't need to render them. We see more detail coming available as we zoom in, right to the point that we start drawing properties, property numbers, and the actual street address, like Frangipani Crescent here. And now you can zoom and pan around and have a very interactive experience with that map. Okay, I think let's have a quick look at the sources.arcgis.com. This is a resource site from ESRI, and this is for all of the software. And then there is a site which is dedicated for developers. Developers.arcgis.com. And here you can get a lot more information on the various APIs that are available. You would typically be interested in the building of the applications. And things like the JavaScript API. What's very nice is they give you an enormous sample set along with the reference, so you can go have a look at how to do certain things. So let's maybe do something like pop-ups. And you've got a working, this screen resolution isn't doing it much justice. Let me just see what is it trying to do. I think it most probably zoomed in a bit far. There we go. These are base maps and there's something called a so-called reverse geocoder. Okay, there's no streets there. Let's just have a look, see if we go and zoom in a bit further. And there you can get your reverse geocode back as an example. You can have a look at how to use this code, and you get instructions how to do these specific pieces, what modules to load, and so forth. Okay, similar information is available for the runtimes. Okay, so this was back to the building applications. And we can maybe have a look at the Android Software Developer Kit. And they have basic walkthroughs, code samples, and many more. Okay, so you can see that ESRI is on GitHub as well. So there's a lot of code and a lot of examples, a lot of information that you can get from there as well. Okay, any questions? How are we doing for time? We good? Yes. So the question was whether you were allowed to update coordinates.
Are we allowed to update the coordinates on the system?
Yeah. What would typically happen is after you've made your pitch and you've given us the requirements, your data requirements, we will create feature services for you that you can store coordinates and put data in there. So you can create there. On the base data, I don't think it would make a lot of sense for you to update things like streets, to say, well, the street's going that way now instead of this way. Am I answering your question? Good. Yes, sir, in the back.
I understand that mostly we will be pulling data from the Arcgis server, but is it possible to somehow motivate that you can actually add extra dimensions to locations and maybe add more data in there?
Yeah.
Certain locations.
I don't see why not. If you can make a pitch for specific data sets and you have that data, we can put that on for you, not a problem.
Okay, thanks.
One more.
Just wanted to know, are we only strictly limited to ArcGIS, or things like Google Maps also do the same thing? So I just wanted to know, for this competition, is it strictly ArcGIS?
No? If you want to use a combination, fine. Be aware of Google's licensing model and the implications of that, but fine. Gentlemen.
Hi. Yeah. In an event that one happens to develop something, even if they don't win, but they go ahead with it, does Esri give free license, or, I mean, especially if somebody was part of this competition? Or will there be a different discussion with regards to the licensing of the Esri platform?
That we can definitely talk about. I think Virosha, just behind you, can also talk to that, maybe if you'd like to. Yeah, Virosha?
So Esri South Africa has a startup program. So obviously we also cater for startup companies that are... we cater for startup companies. So if you're 3 years or younger, and if you have a mobile application that will have an Esri map to enhance your application, we'll take you in and we'll give you 3 years of free licensing software, as long as you qualify to a process.
Okay. Just wait for the microphone. Oh. Oh, here's another. Okay.
Just in case you want to do the request on the server, do we need an API key for the APIs that you showed us now?
No, you don't. These are open services, so anybody can request from them. When you do your application and you have specific data for your application, we are going to secure that with a token just to keep other people out of your services and your stuff. But yeah, currently what you've got there is open.